Weight shift control 5-4 pre-flight and ground operations. Continuing with the powerplant inspection, the pilot should carefully examine the engine attachment to the carriage, paying special attention to security and the presence of any cracks. As a part of this process, it is recommended to shake the propeller to ensure a secure check of the propeller, gearbox, engine, and their attachment to the carriage. Transitioning to the fuel system, the pilot needs to inspect the fuel tank attachment and its overall condition. A thorough examination of the fuel vent system, along with ensuring the fuel supply line is open, is essential. Attention should be given to the fuel pickup, fuel line, and fuel filter, with jiggling of fittings to confirm their security. The fuel pump's condition and security are equally important components in this inspection. Moving on to the induction system, a detailed examination of carburetors, including float bowl attachment and the rubber bushing from carburetors into the engine, is necessary. The fuel lines from float bowls to carburetor inlets also require inspection. The air inlet filter should be checked to ensure it is clean and securely in place. The inspection then extends to the ignition system, with a focus on inspecting ignition system wires to spark plugs, spark plug caps, and wires to CDI units. Ensuring the security and proper fastening of these components is crucial, along with verifying that ignition switches are turned off. Attention is then directed towards cooling systems, where the pilot needs to ensure clear airflow for any cooling system fan or radiator. Checking for potential obstructions caused by insects or birds is paramount. Depending on the cooling system type, air-cooled or water-cooled, the appropriate checks, such as rotating the propeller for air-cooled systems or checking coolant levels for water-cooled systems, should be conducted. The inspection moves to the exhaust system, where the pilot needs to examine exhaust attachment to the engine, EGT senders, and the condition of the exhaust system. Jiggling the exhaust system slightly to inspect the springs holding it together is an integral part of this process. Next, the propeller gearbox undergoes scrutiny. The pilot is advised to rotate the propeller in the proper direction, inspect blades for cracks or nicks, and listen for smooth operation and engine compression. Ensuring the propeller attachment to the gearbox and the gearbox attachment to the engine is secure completes this phase of the inspection. The throttle system should be checked thoroughly, ensuring all controls operate smoothly with proper travel and locking. Additionally, the choke and primer system should be examined for proper operation and travel. Concluding the inspection with a flight deck check, the pilot needs to verify seat security and proper adjustment for both pilot and passenger. Inspection of seat belt attachment and operation is crucial for safety. Gauges should be checked for security and readability after switching on the electrical master, and the ballistic parachute handle should be inspected for security and proper location. When adding fuel and oil, ensuring that the caps are securely replaced is a final, but important, step. Before or after the routine pre-flight inspection, the aircraft should be unsecured, positioned for starting, and ready to enter the flight deck. Key steps in this process include untying the aircraft, securing tie-down ropes, or coiling them neatly if left at the airport. Ground chocks should be removed and secured in the aircraft. A suitable area for engine start, preferably a paved or grassy space away from people and objects, should be identified. The aircraft should be positioned so that the prop blast is clear, with brakes on, throttle closed, and the propeller area cleared. If possible, position the aircraft into the wind for optimal cooling during warm-up. Before starting the engine, an occupant pre-flight briefing is required to inform passengers about safety equipment, exit information, and other essential procedures. This briefing covers seat belt procedures, restrictions on touching certain parts, positive exchange of controls, awareness of ground and air traffic, flight deck entrance and exit procedures, ballistic parachute operation, engine out situations, hand signals for communication, water landings, securing personal items, helmet usage, and other safety systems. Manufacturers of SLSA aircraft typically provide printed briefing cards. After the pre-flight briefing, the flight deck management involves ensuring that all necessary equipment, documents, checklists, and navigation charts are on board. If using portable intercoms, headsets, or a handheld GPS, pilots must ensure that routing wires and cables do not interfere with controls. The flight deck should be organized and checked for loose items that could be tossed about during turbulence. Once seated in the flight deck, the pilot secures the safety belt and shoulder harness, if installed, ensuring they are comfortably snug. Before taking off, pilots quickly run through a checklist. Adjust seats, fasten seat belts, check and practice systems, exchange controls, remove safety pins, don helmets and headphones, verify intercom and radio, and wear eye protection. This ensures a safe and efficient flight. To start the engine, pilots turn on key, ignition, and master power, check gauges and fuel, activate fuel pump, switch on systems, ignite both systems, apply choke, close throttle, engage brakes, clear prop area, announce, clear prop, and start the engine, pull cord or electric. After the engine starts, the pilot adjusts throttle, choke, or enrichener to keep the engine running smoothly, turns on electric instruments if applicable, checks gauges for proper ranges, and monitors the area, shutting down the engine if anyone approaches. It is recommended to maintain a relatively low RPM setting immediately following engine start to allow for proper lubrication on 4-stroke engines and prevent unequal heating on 2-stroke engines. Additionally, on 4-stroke engines, the oil pressure should be checked immediately after starting, and if it does not rise to the manufacturer's specified value, the engine should be shut down to prevent damage. Taxiing is a critical phase of an aircraft's ground operations, and pilots must be proficient in taxi procedures to ensure safety. Upon releasing the brakes and initiating movement, the pilot should immediately test the brakes for proper operation. The method may involve applying power to start the aircraft moving forward slowly, then retarding the throttle while smoothly applying brake pressure. If braking action is unsatisfactory, the engine should be shut down immediately. Yellow taxiway centerline stripes, when provided, should be followed, unless necessary to deviate for clearing aircraft or obstructions. A keen awareness of other aircraft movements in consideration for the right-of-way are crucial during taxiing. The pilot's attention should be focused outside the aircraft, looking to the sides as well as the front, to ensure clearance from obstructions, people, animals, and other aircraft. If there is any doubt about clearance, the pilot should stop the aircraft and verify clearance. Weight shift control aircraft have the advantage of wing tip capability, allowing them to be raised and lowered to clear objects. Setting a specific rule for safe taxiing speed is challenging, as what is reasonable in some conditions may be hazardous in others. Positive control, timely hazard recognition, and the ability to stop or turn without relying heavily on brakes are essential. Speed should be cautious, especially on congested ramps, and low enough to allow prompt stopping when the throttle is closed. A GPS can provide speed information, as airspeed indicators may not be effective at lower speeds. Generally, a rule of thumb is 5 miles per hour or brisk walking speed, with up to 10 miles per hour for long, unobstructed areas. Slowing down before attempting a turn is advisable. During taxi, the wing is typically held in a neutral position, but wind conditions may require adjustments. For example, in a strong tailwind, pitch control may be normal or slightly nose up with wings level. A strong headwind may require nose-down pitch control with wings level. Awareness of quartering tailwind and headwind conditions is crucial for proper wing positioning. A checklist for taxi includes planning the taxi path to the runway, turning on the strobe light if applicable, releasing the brake, checking brakes and steering immediately upon rolling, observing the right of way, and avoiding runway incursions. Pilots must yield to landing aircraft, turn right when two aircraft approach head-on, and recognize the right of way in the same direction or converging scenarios. Special attention is given to avoiding runway incursions by observing all taxiway and runway markings. Clearance must be obtained before taxiing across any runway or entering a runway for takeoff. At a towered airport, this clearance comes from the tower, while at a non-towered airport, it involves monitoring the radio frequency, observing traffic, and announcing position and intentions before crossing or entering a runway. Always stop before the hold short line, and get clearance before proceeding. The before takeoff check is a crucial step performed near the takeoff end of the runway, typically after taxiing. This allows the engine to warm up to minimum operating temperatures, ensuring proper lubrication and internal clearances before applying high power settings. Specific attention is needed for ram air-cooled engines, as prolonged ground operations may lead to overheating. Proper positioning for the run-up with clearance from other aircraft and pointing the nose wheel straight is essential. During the run-up, checks include verifying the strobe light, setting trim, brakes, and conducting an ignition system check to ensure everything is in order before entering the runway. The checklist also involves confirming engine temperatures, EGT, CHT, oil and/or water, and oil pressure within acceptable ranges. At towered airports, obtaining clearance from the tower is necessary, while at non-towered airports, self-announcing intentions and ensuring a clear runway is crucial. After landing, it's important to gradually slow down to normal taxi speed before turning off the landing runway to avoid tipping over. The after-landing check is performed only after the aircraft comes to a complete stop clear of the active runway. Post-flight procedures involve shutting down the engine and securing the aircraft. Key steps in securing the aircraft include setting parking brakes, letting the engine cool down, turning off the ignition switch, electrical units, and radios, and finally, turning off the master electrical switch. If parking outside overnight, it's advisable to put the aircraft in a hangar. If that's not possible, removing the wing and folding it is recommended to prevent damage in high winds.